All right, friends and neighbors, welcome back. Today we are tackling Chapter 12 in the CCNA and analyzing classful IPv4 networks. Now, these are the classful, right? So this is back where we originally started with the structure. But we're also going to do a couple of examples, and we're going to break them out into binary and show you how to work through understanding how your networks are constructed. So in this video, we're going to hit this particular exam topic, right? Configure and verify IPv4 addressing and subnetting. And of course, the subnetting that we're going to do today is really about the classful network. And then we're going to describe private IPv4 addressing and where it fits in with all of this. All right, so this is the category of the exam topic. And we'll follow that up with do you know this already? And a look ahead into analyzing subnet masks. So more subnetting problems, but they'll be a little more in depth. So the concepts that this chapter tackles are the different classes. I'm going to add the class D to that. The default masks and how those work. We're going to remind ourselves about the number of network octets or bits, right? Octet is just another word for byte. And the number of host octets or bits, the number of host addresses in a particular network, the network ID for a network, the network broadcast address, the address that reaches everybody in the network, and then the first and last usable addresses in a particular network. Remember that it's always going to be 2 less than the possible addresses in a network. So here is a very common way to represent all this information. It's in this way in the chapter too. So to start with, we have 5 classes of networking, or 5 classes of network, A through E. Now, each one of those is distinguished by 2 things, really. The pattern that you see in the very first byte or the very first octet, right? It's the first number in an IP address. And then the size of a particular network. And I'll say it now, we'll repeat this a bunch of times. The size of a particular network is governed by the mask applied to that particular network. Okay, so class A, all of those are going to be in the range of 0 to 127. But we'll see here that 0 and 127 are special. So the actual range of class A networks is 1 to 126. So anything beginning with a number that ranges from 1 to 126, you know it's a class A network. Now the reason or the purpose of class A networks is these are large networks. Now it's unicast. What does that mean? Well, these are addresses that can be assigned to a particular host. So I can talk to any one particular host in these. So these are host addresses inside these networks. So the number of networks that are actually there is 126. So there aren't very many of them, but they're all enormous. Class Bs are in the range of 128 to 191, right? We just add 1 and then go up to the next range. This purpose or the use of these networks is they're not as big as Class A's, but they're still pretty good size. So they're medium networks. Again, they're unicast, meaning that we assign these addresses to hosts, and there are 16,384 possible Class B networks. Class Cs are in the range of 192 to 223, so anytime you see that in the first octet, you know that that's a Class C network. These are smaller networks. There are a lot more of them, and we'll see why that is, but basically, again, it goes back to what is the mask. Class Ds are multicast, so these are very special addresses. We use these destination addresses to reach a bunch of nodes, so it's a one-to-many relationship. And that's the range of 224 to 239. Class E is reserved, although we have the use of the all 255. So 255, 255, 255, 255 is a special address as well. Okay, let's get some more related facts. Well, one thing that we've got to remember is that whatever class of network, it comes with a default mask. So in a Class A network, you have 8 network bits. Well, we know that because that's where the binary ones appear. Now, I'm going to show that to you. But for right now, what we're going to remember is that a Class A network has 8 network bits, and a Class A network has 24 host bits. or these are the bits that are allocated to hosts in a particular Class A network, which means that there are a lot of unique addresses inside a Class A. So the default mask then is 255.0.0.0, which also means that each network has 16 million possible hosts in it. And then just take 2 away from that, and that's your usable. Now, Class Bs are the next step down. So there are 16 network bits and 16 host bits. Now, actually, we say a lot of times that there are 14 network bits because of the patterns that are allowed. So we'll say 16 or 14 because it's just the first collection. On the exam, I think they're going to say 14, so go with the book. And then the mask is going to be 255.255.0.0, which means that there are 65,000 possible hosts per subnet, 65,536. But of course, the usable is 65,536 minus 2, or 65,534. And the reason that we subtract 2 from all of these, right, we saw this last video, is that you've got one address that goes for the network ID and one address that goes to the broadcast ID, so we don't assign these to hosts. Now, a Class C network, these are much smaller networks, but there are a lot more of them. So we have 24 network address bits, so lots more networks, and only 8 host bits. But that means that each Class C network still has 256 possible addresses, 254 that we can be allocated to hosts. And the default mask is 255.255.255.0. Now this isn't in the chapter, at least not directly, so I'm gonna say it here because it's part of what we're talking about. I like to remind us about the masks because there's actually a logical operation that goes on, right? We say, remember this and remember this, but if you understand how it works, you don't have to remember it. You just do what the designers intended. Okay, so here's what I mean by this. If we take the Class A networks, 0 to 127, if you took that first octet and you converted them all to binary, what you would find out is that the first digit in the binary for all of those is 0. And the default mask of 255.0.0.0 in binary, it looks like this here, right? And the red portion, that's the number of bits allocated to host addressing. So lots and lots of bits for host addresses, not very many for networks. And then we always have a graphic, kind of like the one above me here, where we say what are the parts that are allocated for network and host. Well, you can see that there aren't a whole lot of bits for network. There's a whole bunch for host. So that's Class A. Class B networks, 128 to 191, if you did the binary for all those numbers, you would see that all of the values shared a 1 and a 0 in the first couple of bits of that first octet. And then breaking the mask into binary, it looks like this, right? And then we've got the representation here in the graphic above me. So that's what we're doing. Class C's all share a same binary pattern too, 110. So the addresses from 192 to 223, if you did the binary for all of those, that would be the pattern at the beginning. All of them would be 110 at the beginning. And the same thing with multicast. Okay, so if we remember that, right, because we're really talking about binary, because that's how things operate. There are lots of shortcuts, but binary is what it all comes down to. The other thing that we have to remember is there's a logical AND. So what we are actually doing with IP addresses is we convert IP addresses to binary, we convert the mask to binary, and then we do a bitwise ANDing process that I will show you later on that dictates the network address or the network upon which you reside. And that's the magic. That's the under the hood look. All right, let's talk unusual network IDs or network addresses. So in Class A, we know the range is 0 to 127, but we do not assign 0.0.0.0 or the 0 network to anybody. And 127 anything, most commonly 127.0.0.1, is the loopback address. So we don't assign that network either. So that's why we say the range is actually from 1 to 126. And we also can't forget that there's the TENNet that's part of RFC 1918. So that is also carved out of that space, at least for public addresses. Now the Class B range is technically 128.0.0.0 to 191.255.0.0. And even though 128.0.0.0 looks like a Class A because of all those zeros, it's not. It's a Class B because of the beginning pattern. And 195 or 191.255 looks like a kind of a broadcast address, but it's not. So it still belongs to the Class A network space. And then we have to remember the Class B RFC 1918 addresses of 172.16.00 to 172.31.255.255 or 172.31.0.0 for the last network address. And 169.254 is a special address allocated for what we call auto config or zero config, also called the PIPA addresses. These are the ones that are automatically assigned when you don't have services. Now in the Class C range, we've got 192 to 223 in the first octet. The range of networks would be 192.0.0.0 and 223.0.0.0. Those kind of look Class A-ish again, but they're not because of the beginning pattern. And if we look at the last possible address, the last possible network, it would be 223.255.255.0. And again, that looks a little bit like a broadcast, but it's not. And lastly, we've got 192.168.0.0 as being part of RFC 1918. So we have to, these are all sort of the special addresses out there. Now, if you wanted to see where these were, where could you go, right? Am I just making this up? Where did the CCNA get all of this stuff from? Well, you can look at the RFCs. So here is RFC 791. As you can see, it dates from 1981. And if you scroll down to the addressing section, you can see all of this. And you can see the bit pattern that I talked about, 0 for Class A's, 10 for Class B's, 110 for Class C's. And we can see the descriptions here. Okay, so again, because we're dictating these, we really say that there are 14 bits of address space available for the networks in Class B and 16 bits for the host. But in Class A's, because we're dictating this, we say there are 7 bits of network address and 24 bits of host address and so on. So that's where you would actually find those. Well, what about the private addresses that we were just talking about? Well, this is RFC 1918 from 1996, and we can see right in the middle of the RFC, the address space is described. Now, one thing that's a little tricky here is this /12. So we got /16. So first of all, when you see /8, /12, /16, /24, this is CIDR notation, right? We've mentioned this before, but this is CIDR notation for classless interdomain routing. Well, the /8 makes sense for this Class A network, but what about this /12? Well, it's /12 because we're specifying a particular range, right? So it's got to start with 172.16, but then the mask would be /12, and that would get us up to 31. So that's why it's a /12. And the 16 is used here because we want all of the space allocated to 192.168. We don't want it really Class C sized. It's a Class C network by number, but the space allocated for this particular private network is a little bit larger than that. So that's where you would actually find those two sets of addresses. Now, the book describes a very nice process for figuring out all of your numbers that you want to work with. So there's no substitute for just getting in there and trying a couple of these. I'm going to do a couple of examples for you, and then you should take a couple of whacks at these, do the book examples. I'm going to make some new examples up so that you can actually do them and understand what you're doing. So the first thing that you do when presented with an IP address is you say, what class of IP address is this? What is the class of network to which this address belongs? So you look at the first byte or the first octet. And then you say, okay, well, based on that first byte, I know that the network bits are here and the host bits are here. And then what you do is you change all of the host bits to 0, and that's your network address. Or you could simply say, here is my class, or here's my IP address. I'm going to AND it with the mask, and I'll get the same number. Now, to find out the first usable address, you're just going to add 1 to that. For the broadcast address, we're going to take all the bits allocated to a host, and we're going to say, let's convert them to 1. That's the broadcast address. To find out the last usable address, you just subtract 1 from the broadcast. And there you have it. That's all the numbers that we want to know, at least for this particular chapter. Now, what's not in the chapter is the ANDing process. I'm going to show that to you so you have it a couple of times in your brains. But what we need to understand is that there's a logical AND, right? So here's an AND gate, and here's the truth table for AND. So this is my 2 inputs, my A and B. And if I have these 2 inputs, here is my output. There are 2 important things to remember with an AND. Anything ANDed with a 0 gives me a 0. The only time I get a 1 out of an AND gate is if I have 2 1s on the input. So A and B both have to be 1s, and then I get a 1 on the output. Otherwise, I always get a 0. Okay, let's do some examples. So we're going to start with this. Now, if we follow the exact structure of the previous slide, what I would do is I would say, okay, first thing I want to do is, what is the class? Well, based on the first octet, I know that this is a class C. Right? I also know that because of that, it has a mask of 255.255.255.0, which also means that this part right here, right, is my host portion. If I take the host portion and just make it all zeros, now what they really mean by that is to convert the binary, but we'll show both. So what I really do here, the class structure is really, really easy, so it's a little misleading. So that's why we're going to do both. So here if I do 210, 205, whoops, 205, 200, and then I just say put zeros in the host portion, well, that's my network address. So my network address in this case is 210.205.200.0. But what really happened there? Well, let's convert the whole thing to binary. So 192, what is this, 208. So I'll just do the conversion, and then I'm going to probably fast forward through this part, but we'll do the conversion. Okay, so here is our IP address converted to binary. We know that this portion is the host part of the address. Well, how do I know that? Because if I convert the mask into binary, the zeros tell me where my host portion is, and the 1s tell me where the network portion is. So now what the book rule says is that I want to take the host portion and convert that to all zeros. So I would take this whole thing and convert the last octet, let's see, is that it? Yep, to all zeros. Now that would give me my network address of 210.205.200. So that's what's actually happening. But if I said, well, wait a minute, what if I just do the ANDing process? Right? So if I AND this address with the mask, what I do is I say, I remember the rule, anything ANDed with a 0. All right, so I'm going to skip a line to see what would happen with the ANDing process. Well, I would look right here. 1 ANDed with a 1 gives me a 1. 1 ANDed with a 1 gives me a 1. 0 ANDed with a 1 gives me a 0. 1 with a 1. And I get a whoops. 0, 1, 0, 0, 1, 0. So all I did was take the top value and run it through the logical AND. with the bottom value. So what happens when you have all ones? Whatever was on top pretty much comes down. And the same thing would happen here. Now what's actually happening, right, is when I have two ones, I get a 1, and anything else results in a 0. So that's the ANDing process. So it's easy to do shortcuts, but we don't have to. We're doing a straight up AND. Well, here we've got all zeros. So all of these get wiped out because we're ANDing with zeros. So I would get just like this. And so this answer that I get from the ANDing process is the exact same answer that I got from up here. So the next question is, what is the first usable address? So if I was to say, what are my possible addresses? I would say that the range in the last octet is 0 to 255. But I also know that that's not the usable address, so the usable addresses are 2 less than that. So the usable is, right? I just know that. These are facts that I know. Well, where do they actually come from? Well, if I take my address here, right, and I just said I'm going to add 1 to it. Right, we're just going to add 1. Then what I would get when I was done was this. And this address is 210.205.200.1 right there. So that's my first usable address. Okay, well, let's do the broadcast thing. Well, in the broadcast rule says that I would take my starting address, right, figure out the host portion. I would take the host portion and convert it to all ones. So I would do this. There we have it. So that is my last possible address. Well, what is the usable addresses? Well, let's take this broadcast address, right? And what I'm going to do now is subtract 1. And what I get is that address right there. Well, this address is actually 254 right there. So that's how all of this works. So that's how you work through an example. But really what we want to remember is that we're talking about binary here. And there's another process. There's a logical AND that we do with the mask that tells us what's really going on under the hood. Now, when we subnet or supernet, we're changing this boundary right here, and therefore changing the size of the host address space. All right, let's do our other example. So I broke out in binary to save a little bit of time, but let's go through the steps. Well, if I look at this address and I see that it's 180, I know that that falls in the 128 to 191 range. So this is a class B. And so I know that the mask for a class B is 255.255.00 or /16. Now I could automatically say, okay, because it's class full, I could get away with saying, oh, I'll just put zeros where the host portion is, and I know the host portion is these 2 octets right here. So I could say, oh, well, that's simply 180.179.00. And I could totally get away with that. And the range of hosts, I know, I just say, well, what's the range that's possible in this particular network? Well, it's 180.179.0.0, and that goes all the way to 180.179.255.255. The usable, of course, would be 180.179.0.1 to 180.179.255.254. So these, I know that because we've been doing this a million times. But what if I only had the binary to work with? So let's do that now. So the rule says take the host portion and convert that to all zeros to find out the network. Well, that's this, right? So I could just do that, follow that rule, and I would get, that would be my result, which would be this address right here, okay? Or I could do the ANDing process again. I could say, what's my mask? Now, if I do the ANDing, what I would get, right, when I AND all these, we know that if it's all ones, I pretty much just bring down what's on top. Because again, 1 with a 1 gives me a 1, 1 with this 0 gives me a 0. So the result here would be that out front, and in the mask I have all these zeros. Anything ANDed with a 0 gives me a 0, so I would do this. And again, for a completely different reason and process, we have the network address. Okay, so two really, really good techniques to use. And what we'll find out later is that if you use the binary, you will never go wrong. Well, how do we find the first usable host? Well, we just do this, right? We say plus 1. And what I get is that. So 180.179.0.1. There it is right there, the first usable address. Well, how did we figure out the broadcast address? Well, we took this same line. We said that is my IP address, and I'm going to convert the host portion to all ones. So I take the network portion and I leave it alone. But then I take the host portion and convert it all to ones. Now it's a class B, so I've got 16 of them now. There we have it. Well, what's this address? This address is the broadcast. It's right there. 180.179.255.255. Well, how do I find the highest usable address? Well, I take this broadcast address and I subtract 1. And I get 180.179.255.254, which is right there. Well, I hope these examples help you through your workings on IPv4 classful networks. Okay, did you know this already? Well, now we're really, really well equipped to answer these, but here we go. Which of the following are not valid Class A network IDs? Choose 2. Both B and C, 130 is not valid because that's in the Class B range, and 127 is loopback, so that's not valid either. Which of the following are not valid Class B network addresses? Well, E, all of the ones in the book, they're actually valid, so there's nothing wrong with any of them. Which of the following is true about the address 172.16.99.45's IP address? Choose 2. Well, the answers were B and D. This is a Class B network, and there are 16 host bits. We know that because it's Class B, and so the 9945, that's a representation of the space that is allocated to the host portion. Which of the following are true about IP address 192.168.6.7's IP network? Choose 2. Well, this is a Class C, and so we know the network address is 192.168.6.0. We also know that the default mask for Class Cs is 255.255.255.0. Which of the following is a network broadcast address? Well, the only answer that fit was 172.30.255.255. Remember that the entire host portion has to be converted to ones, so that's why it's 255.255. The Chapter 13 look ahead, we're going to do some analyzing of subnet masks, so we're going to dive right in there. We're going to do some conversions, we're going to do some design choices, and we're going to do more of the binary stuff. We're going to take a look at the binary conversion to the dotted decimal or DDN masks. And then we're going to talk a little bit more about network broadcasts. Well, all right, this has been analyzing classful IPv4 networks, right? We did the classful story, the ABCs. We did our ranges. We know that each network has a possible set of addresses and then a smaller usable set of addresses. We know the network ID and what those broadcasts are for. And each class has a number of networks that can be built in that class. And each network within the class has a certain number of hosts added. And that is entirely based on the mask for that particular class. And of course, we broke down a host address. We have a process now that from a default addressing scheme, we can find the network address, the broadcast address, we can do the binary, we can do all of that stuff. So again, next up we'll be analyzing masks and such, and of course on the channel there's lots and lots of support stuff, lots and lots of other videos. Well, thanks for watching, thanks for listening. May those packets always reach their destinations, and of course this is CCNA. You can do this.